Hi, my name is Shahroz Ahmed, and in this video we are going to discuss a topic of Calculus 2, and the topic that we are going to discuss is parametric equations. So what are the parametric equations? Let me just write it down first of all. So a parametric equation defines a group of quantities as a function of one or more independent variables. So I can just write it over here, the definition. So a parametric equation is defines a group of quantities as function of one or more independent variables called the parameters. For example, let's suppose we discuss the motion of an object that is falling from some height, and the motion of the object is projectile motion like this. All right, now we are going to write down the parametric equations that will define their horizontal motion and the vertical motion. As you can see over here, the object is moving in both the direction. It is moving in the forward direction, like towards right, in the horizontal direction, and also it is moving downwards, that is its vertical direction. So we are going to write down the two equations for its motion, and those two equations will be represented in a single variable. That variable will be considered as the parameter. So for the horizontal motion, the equation will be like x of t equals to 5t plus 10. So let's suppose this is the equation for the horizontal motion. Now for the vertical motion, we can write down y of t equals to 50 minus 5t square. So let's suppose we want to find out the horizontal and vertical position of this object at this point, and at this point let's suppose the value of t is equal to 1. So in order to find out the horizontal motion of this, like let's suppose this is the equation for the horizontal displacement and the vertical displacement. So in order to work out the horizontal displacement, we will put t equals to 1 into this equation, and in order to work out the vertical displacement, we will put t equals to 1 into this equation. So this is how we have set a parameter for the horizontal motion and the vertical motion of this object. So such combination of equations are called the parametric equations. All right, now we will see how we can take the derivative of the parametric equations. So let me just write down the two parametric equations, then we will see how we can differentiate our parametric equations. And why do we need to differentiate it? We need to differentiate in order to find out the rate of change of the object at a certain point. If you want to find out the rate of change of motion of this object at this particular point, then we have to take its derivative at t equals to 1. So let's see how we can differentiate them. All right, so the parametric equations differentiation. So let's suppose we have two parametric equations in terms of t. So the first one is x equals to 2 sine 1 plus 3t, or we can say 3t plus 1. And the other equation that we will have is 2t cube. So these are the two parametric equations, and we want to find out the derivative dy by dx. So for this purpose, we will use the chain rule. The chain rule says that dy by dx will be equal to dy by dt times dt over dx. So we have to work out the derivative of both of them with respect to t. We'll insert their values over here, and we'll get the derivative with respect to x. So dx over dt will be equal to, for this one it will be like 2 cos 3t plus 1 times the derivative of this function, that is equal to 3. So the derivative of x will be equal to, with respect to t, will be equal to 2 cos 3t plus 1 times 3. Now it will become 6 cos 3t plus 1. And now we have to work out the derivative of y with respect to t. So dy by dt will become equal to 3 times 2, so it will become 6t square, the derivative of y with respect to t. Now we'll insert the values over here. So dy by dt is 6t square, and dt by dx will be the reciprocal of dx by dt. So that will be equal to 1 over 6 cos 3t plus 1. So 6 will get cancelled, and our answer will be equal to 1 t squared over cos 3t plus 1. So this is how we can differentiate the parametric equations by using the chain rule. Now in the next example we are going to see how we can take the double derivative of the parametric equations. So for the second derivative, let's suppose we have two equations in terms of t. The first one is x of t equals to 3e to the power of 2t, and the other one is y of t equals to e to the power of 3t minus 1. So we will take the first derivative the same way we did in the previous example. So dx by dt will be equal to 3e to the power of 2t times 2. So it will become 6e to the power of 2t, and dy by dt will be equal to e to the power of 3t minus 1 times 3. So it will become, well, for this one it's only e to the power of 3t, e to the power of 3t. So it will become e to the power of 3t times 3. So it will become 3e to the power of 3t. So dy by dx will become equal to 3e to the power of 3t times the reciprocal of this one, that will be equal to 1 over 6 e to the power of 2t. So this 3 will get cancelled, this is 1, over here we'll have 2, so and this will become 1 over 2 e to the power of t. So this will be our dy by dx in terms of t. Now we have to take the double derivative. So the double derivative will be represented by d square y over dx square, that will be equal to d by dt of the first derivative divided by dx by dt. So this is how we'll take the double derivative. So I'll just insert the values over here. So it will become equals to d by dt of half e to the power of t whole divided by 6 e to the power of 2t. So I'll just do this simplification over here. So the derivative of half e to the power of t will be same as it is. So in the numerator we'll have half e to the power of t, and we will divide it. So I'll just write the division sign over here to make things simple. E to the power of 2t, and it will become half times 1 over 6. It's like e to the power of t over 2 times 1 over 6 e to the power of 2t. So it will become equal to 1 over 12 e to the power of negative t. So that will be the answer. So we can write it as 1 over 12 e to the power of t. That's the double derivative of our parametric equations. So you have to keep in mind this formula in order to take the double derivative of the parametric equations. Alright, so now we have to discuss the next topic, that we have parametric curve arc length. How we can measure the arc length if we have been given the two parametric equations. So let's suppose we have a curve that is described by the two parametric equations. So the curve is like this. It starts off from here and ends up over here. This is point A, this is point B. The coordinates of this curve are represented by the parametric equations such as x of A and y of A, and the coordinates of point B are represented by x of B times y of B, and this point will be equal to t, and over here we can write the parametric equations of point B in terms of t. So the formula in order to work out the arc length will be equal to, I'll write it over here. So arc length will be equal to square root Before that, we will have integral sign from a to b, square root the derivative of x of t whole square plus the derivative of y of t whole square, and we'll put it underneath the square root sign. So we'll integrate it from a to b, and we'll get the arc length from point a to b. All right, so let's do an example for this one. And in the example, let's suppose we have a curve that is represented by the parametric equations, which are x of t equals to cos of t, and y of t is equal to sine of t, and we have to do this integration with respect to t. So we can use this formula of the arc length in order to work out the length between the 2 points. That we have to find out the length of the curve from point 0 to pi by 2. So let's use it and find out the arc length. So we'll have x bar of t will be equal to minus sine t, y prime of t will be equal to cos t. So the arc length will be equal to integration from 0 to pi by 2 square root the square of this one, that will be equal to minus sine t whole square plus the square of this one, that is cos t whole square with respect to t. So it will become from 0 to pi by 2, and it will become sine square t plus cos square t. That will become equal to 1 in the next step. So from 0 to pi by 2, radical 1 of dt, that will be equal to 0 to pi by 2 1 dt. So its integration will be t, and we have to put the limits from 0 to pi by 2. So it will become pi by 2 minus 0. So the arc length will be equal to pi by 2. So this is how we can work out the arc length between 2 points by using the concept of the parametric equations. So this is it for this topic. I hope this was just the introduction and how we can use the parametric equations to find out the arc length, and how we can differentiate them, how we can double differentiate them. So this was it for this this lesson, and I hope you understood it. Thanks a lot for watching the video.